Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's Security Boulevard webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great webinar on tap. I'm really excited about this one. I think this is going to be a really fascinating topic. But before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during our presentation you have a question for either one of our speakers, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions, and we'll try to get to as many as we can near the end of today's webinar. Also, at the end of today's webinar, we will be doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is best practices for driving software quality through a federated application security responsibility model. Our speakers today are Joanne Godfrey, who is the Director of Product Marketing at ZeroNorth, and Thaddeus Walsh, who is a Solution Architect at ZeroNorth. Joanne, Thaddeus, thank you so much for joining me today. Really appreciate you being here.
Thank you, Charlene, and welcome.
Go right ahead. I'm gonna put myself on mute. You go knock yourself out. Go ahead.
Thank you, Charlene, and thank you, and welcome everyone, and thank you for joining our webinar today. So I'm going to take the first about 5 minutes to provide some context, and then Thaddeus will get into the best practices for a federated AppSec responsibility model. So over the past decade, DevOps has revolutionized the development process, but for the most part, application security tools have remained the same for the past 20 years. They're designed for the technologies and infrastructures of the past. And yes, we have seen some new security scanning tools added to the mix, but these technologies are still focused generally on identifying vulnerabilities and defects at specific points in the software development lifecycle without taking the broader build to deploy development process into consideration. And this becomes more problematic when you consider how the world has changed, especially over the past 5 years, and even more so over the past 8 months. It's now a software-driven world. Every business is a software business, and software is the competitive advantage today. Time to market is critical, quality matters, security matters, and while DevOps accelerates software production, security can't keep up. And this opens a huge chasm, a huge risk chasm. So what does that mean in practice? It means that security has very little visibility today, and certainly no broader context into the security of an application or the state of application vulnerabilities. And it means there's no way to assess the risk of an application and the impact of that risk on the business. And there's no way to figure out whether to prioritize and how to prioritize remediation. And because of all of this, it means that remediation slows down DevOps processes, which creates conflict between development and security. And part of the problem is that the DevOps model utilizes a decentralized approach to deliver software fast, yet security, risk, and compliance remains in the past. It's traditionally the CISO and their team would set and oversee policies for the security policies for the enterprise. And this centralized control model no longer applies to today's software-defined DevOps world. Today, product security teams are often embedded within engineering organizations, and these teams are chartered with ensuring the security of their respective product lines while incorporating the risk that their businesses are willing to accept. These teams are also deeply understand the delivery requirements placed on the development teams for velocity. And within this context, product security does what it takes to support their product lines at the speed of business, which can create competing and conflicting demands between product security at the line of business line and enterprise security at the corporate level. So to work effectively in today's new world, there needs to be a new decentralized federated responsibility model for application security. And really, what can this federated responsibility model look like? What should it look like? So first, there is a need for enterprise control. You still need to set standards for application security, risk, and compliance that are maintained at the enterprise level so that the organization can assess these issues holistically and make operational decisions for the business accordingly. Viewing and assessing security risk on an individual product line by line basis can only provide a partial view of risk and when viewed at the enterprise level, could generate an inaccurate or misleading picture and lead to a misaligned business decisions. So to get a holistic perspective, you still must define and codify security policies in a centralized, normalized way in order to enable an apple-and-apples comparison and generate consumable board-level reporting. But at the same time, you still need to allow policies to be enacted locally based on risk criteria that is specific to the line of business or application. Because every application is different, every business line is different, and therefore the risk profiles are going to be different. Second, it's important to maintain control at the enterprise level, but this control must also work with the product level to accelerate the velocity of application delivery. And this really means being able to seamlessly integrate security scanning within DevOps pipelines using automation and orchestration. This allows for developers to find and fix security vulnerabilities while they're developing without slowing down their work. And this means centralizing and normalizing and streamlining vulnerability findings into meaningful and manageable outputs that enable them to remediate these vulnerabilities far more quickly and easily. And as an added benefit, it's going to reduce the friction between security and development teams, which is going to help to accelerate the velocity of application delivery. And the third piece is that the Federated Responsibility Model must deliver a value proposition that empowers developers to apply security throughout the SDLC, throughout the software development lifecycle, in a way that meets the needs and provides the required visibility of security without it getting in the way of existing processes and velocity. Security must be transparent to the developers. It cannot create frictional disruptions, and this means enacting security in the background without the developers having to interact with the security tools unless they specifically want to. Alternatively, providing developers with the ability to use the tools that they choose while still enabling corporate visibility. So this means prioritizing vulnerability remediation based on risk and business impact, so that they only need to go back and fix what they really need to fix and are not flooded with unnecessary work. So the implementation of a federated responsibility model will be unique to each organization. They will need to find the right balance between to create an integrated partnership between the different teams and their different approaches, attitudes, and business requirements, while factoring in people, processes, as well as technologies. But ultimately, this model will enable organizations to meet enterprise control requirements while empowering the security and operations teams with the structure, with the policies, and the technology that they need to deliver secure applications at the velocity that's required in today's new economy. So now let me hand over to Thaddeus, who's going to discuss some of the challenges and the solutions to those challenges for implementing this model in real life. Thaddeus?
Thanks so much, Joanne. And thanks everybody for joining us today. As Joanne mentioned, I'm going to walk us through some of the hurdles and challenges that we typically see. So this is the list here. We'll walk through each one and talk about some of the strategies to overcome these sorts of barriers in the transition from a traditional application security program responsibility model to a federated responsibility model. So the first is uniform buy-in. So inherently, we're talking about change. We're talking about change of responsibilities, and that oftentimes is met with resistance. So we need uniform buy-in in order for the federated responsibility model to work properly. If the developers don't want to fix things or are not willing to remediate issues, then your risk will not be reduced. If the head of line of business does not want to mediate or intermediate the deliberation on prioritization or what needs to be fixed when, given the risk calculus of the business, then you sort of reach impasses and things like that. So the teams that we're talking about, Joanne alluded to this, there's the application security team or the product security team. Very likely many of you in the audience, hopefully it's not a problem for any of these folks to lean in and actively engage in an application security program. There is obviously the application development team, the folks that are writing the code and designing the application. There is typically either a designated or an embedded within that application or engineering team operations function. So that's going to be your DevOps team or a designated IT operations team, and then the business leadership and or corporate governance. So if you have very crystal clear defined risk tolerances or risk policies, that may be somebody who doesn't directly own the application from a line of business perspective. If you don't have those policies in place, it really does need to be whoever owns the application from a business perspective. And so why would anyone not want to embrace a federated responsibility model? Well, you've got your traditional who moved my cheese, that's not how we do things type responses. And you'll see that with any sort of change in the business world. The second piece is security is outside of their comfort zone. So we see this a lot with folks in business leadership positions, folks in the IT operations sphere. If operations for your organization is very heavily functional operations, recovering services when they go down and things like that, not necessarily security response or security operations. And oftentimes application developers don't feel fully qualified to dialogue intelligently about some of the nuanced and complicated security vulnerabilities that the tooling can identify. And then finally, it's unclear how application security ties into their role. So these are some of the common reasons why folks sort of attempt to elect out of participating in a federated responsibility model. Everybody's responsible for the security of the application. Everybody is needs to be a contributor to that process of securing the applications. So how do you encourage that sort of a lean in? The first one is olive branches. Anytime you're bringing stakeholders together that have sort of differing directives or differing incentive structures, it's very useful to leverage what I refer to as olive branches, which are essentially artifacts or deliverables that the various stakeholders can't get anywhere else. So providing very useful reports that can't be produced out of the tool set or the landscape that the application developers work within, providing a more strategic view. So oftentimes developers will sort of pore over very complicated service mappings or architectural diagrams that are extremely tactically oriented, but there isn't necessarily a picture of where do each of these services reside. Is this in our data center? Is that in AWS? Is this in Azure? And a clear sort of strategic level picture to help translate the information into maybe more broad audience applicability. And then finally, simplifying something those stakeholders have to perform periodically. So if payment card information passes through an application, you gotta go through a quarterly PCI assessment review. And those periodic sort of low frequency processes oftentimes are the bane of a team's sort of workflow. And it can be very disruptive because oftentimes it's senior members of the team that have to perform those, compile those reports. And if you can make those easier by operating your application security program in a way that the data is sort of available at the snap of fingertips, that's a huge value add that you can bring to the application development team or the operations team, whoever's responsible for generating sort of the technical review in those regards. So olive branches are great. You can show up with, any sort of gift you can design, but if you don't acknowledge headaches from the past, if there are any, you're very likely not going to make it very far. So oftentimes, application security teams have, over the last 5 or 6 years, attempted to inject or insert static assessment into build pipelines. It's a great example. All the tool vendors were talking about it. Everybody in the security world was sort of talking about breaking builds and scanning as part of pipelines. And in many cases, the application security groups were kicked out of the pipelines due to problems with interoperability, problems with stability. Breaking builds is not necessarily a great way to encourage collaboration. And so oftentimes those initial engagements at the recommendation of vendors or at the recommendation of sort of application security pundits would have caused a lot of friction between teams, between the stakeholders that we now need to come together. And so reframing application to present as a resource to support development and not as a barrier to delivery, that's critical. If you have had sort of, shouting matches or code ripped out of pipelines or whatever in the past, you really have to just accept that, acknowledge it, and say, we're doing it differently now. And then finally, proof in doing. So everybody knows one application lead, security champion, somebody who is technically capable, who is friendly to the security team, who is willing to sort of lean in more so than their peers. And that's awesome. Find that person, work with that person, leverage them as the guinea pig, leverage their applications that they manage or that they oversee as the guinea pig. And once you have a working model within the context of your organization, it becomes much easier to show off what you're providing, show the olive branches that you're providing to that application team to other application teams and say, this is how we did it, this is how long it took us to stand it up, and this is the benefits that we're seeing. So the next challenge that we see is really comes from the complexity in application security assessment processes in general. So every integration between AppSec tools and the dev ecosystem appears to be consistently inconsistent. Application portfolios are diverse. You've got different code languages, web app frameworks, application architectures. Is it monolithic code bases? Is it microservice architecture? Is it API driven? Is it, what's the back end look like? Is it a DocuStore? Is it a relational database? Is it a map reduce table? And what are the build processes? What are the CI/CD platforms that the application team uses to build? What does their QA process look like for regression testing, if it's a web application, for functional unit testing in a dynamic sense? That could vary wildly from team to team because they're building different applications and you use these different pieces of building an application to meet certain demands of the functional requirements of the application. Similarly, on the application security portfolio side of things, you have a wide variety of different scan types. You have varying sort of support and affinities for languages or frameworks. You have different scan execution models for these different tools. So even within a software composition analysis tool, you may have an agent-based assessor, which would live on the build agent, as opposed to a host-based assessor where you may have an agent, but it doesn't do analysis. It delivers a payload to some remote host that performs the analysis. And that can impact why, how, and where you sort of incorporate those assessments into the pipeline. And then finally, data outputs. Nobody in the security world can agree what the heck to call the highest severity, what the scoring metric to use. We have things like CVSS, and we've gone through 2.0, and we're now in 3.0, and there's like a 3.1 that sort of is in its somewhat infancy. And so you get wildly variant risk scores, levels of verbosity within the scan output, remediation instructions, and just how the issues are carved up. So what does an atomic issue look like? Do I collect this data together at all? Do I have one instance for every time that particular type of finding was found? And then finally, which scanners and how to implement them may vary across your app portfolio. So if you've got 15 applications and you've got 5 different scanning tools that you could use, maybe with some overlap, you may have 20 or 30 different sort of individual integrations between tools and pipelines, tools and pipeline platforms, that sort of thing. And so how do you solve for what appears to be an intractable integration mountain? Because you could spend a year just getting one tool running effectively within one pipeline platform. And if you have 4 pipeline platforms in, across 20 or 30 applications, or even 4 applications, you're not going to get very far. It's going to take you a lot of manpower and a lot of time to start realizing efficacy in your application security program. So what's important is identifying that there are some meaningful attributes that you can sort of bucketize your applications into. So coding languages, do your static assessment tools support those languages? How do you address languages that maybe none of the tools really support well? Golang is a great example. There's sort of an underrepresentation within the the commercial tooling space of sort of good quality Golang assessment rules. Some vendors are way ahead of others. And, what are the CI/CD platforms? What are the release processes involved? And really importantly, how do your web applications handle user authentication? And is that already a solved problem? Does the application team already have a methodology for executing remediation tests beyond the login page? And this can be a huge problem for instrumenting within release pipelines, because application developers build login pages specifically to prevent software from passing through the login interface. The whole idea is you want to ensure that it's a human, so we make it difficult for compute systems to make it through. And so you can either hard code credentials. That's not a super great idea, but a lot of people do it. You may use a passwording vault. You may have credentials sort of drop loaded into a QA only build of the environment. Sort of, there's a million ways to address that. But the ideal case scenario is that your developers have already come up with a way to get through the login page. And if they have, you can sort of co-opt that. So once you start bucketizing the applications in this sort of a matrix, like in this case, where we're on this build platform, one of these three languages, we want to run this SaaS tool. And you'll start to find that what appears to be this infinitely complicated sort of array of options really boils down to a couple of playbooks that you can leverage sort of in a repeatable fashion. What we see is organizations tend to hire developers with some level of overlapping skill sets. And so you'll see consistency. Do you have a lot of Java apps? Do you have a lot of .NET apps? So on and so forth. And you'll start to, as you sort of work through app by app, you start to develop these playbooks that make it easier to do instrumentation and implementation. So based on those differentiating attributes, you can put together standard plays and implement in a more sort of consistent fashion. You still need to babysit those integrations, because if the vendor changes their API authentication layer, you got to account for that. Otherwise, you're breaking builds. But it tends to be very daunting, but you can get there. You can certainly get there as a new AppSec program, because you can make tool selection decisions that help you a lot. And then finally, normalizing and abstracting the scans so that development and DevOps don't have to see how the AppSec sausage is made. Ideally, you're using human readable name declarations if the application teams are declaring the scans themselves, or you run background processes or parallel pipelines that trigger off of dev pipelines, or you come up with a way to run scans asynchronously so that you're not asking the development team to wait 2 hours in the middle of a 15-minute build because your static tool likes to just sort of chew the fat and take its time. What's really important is sort of operating in parallel without being disruptive to the build and release process. So the next issue, let's say you wave a magic wand and you've got integrations galore. All of your applications have tools implemented in an orchestrated fashion that are not disruptive to the release pipelines. The next sort of issue that you would naturally run into, and certainly in most cases, you run into these issues in parallel. But once you have a set of findings, what do you do with them? Routing is one of the most difficult problems for even small organizations to solve. There's a sort of a cognitive phenomenon where, and I've yet to meet somebody that can't sort of identify with this, where if you receive a communication that is addressed to multiple people and the contents of that communication don't apply to you, you will cognitively suppress those messages in the future, meaning you create your own attention blindness. This is part of like what makes humans great at surviving. It's also part of what makes humans terrible at managing email workflows or email-driven business processes. Because the first time that you open the email and none of it pertains to you because it was sent to all of the development leads or everybody in the operations team or what have you, you sort of check it out, you look at it, you read through it and you say, oh, this doesn't pertain to me at all. The next time you get that email, you very likely won't even open it. And so if you're the person that's responsible for remediating an issue, or if you can imagine that you're the person who's responsible for remediating a particular issue, and you get that email, 2 or 3 months from now, after you've stacked up 2 or 3 months of these messages that you don't open, you wouldn't be aware that there's an issue. So you're never going to address the problem. So furthermore, it's not always obvious to the application security team or in general who is responsible for fixing a given issue, because you may have a tooling suite that's embedded as part of an application that's maintained by a different development team. And so even though that code shows up in application A, it's actually maintained by the team that operates and runs application B, but you found it while scanning a build for application A. That can get extremely complicated. And so it's ultimately incumbent upon the application security team to intelligently route these issues to specifically the right people or teams in a way that engenders their engagement, essentially avoiding that cognitive disconnect that I talked about at the top of this slide. So how do you do that? You probably have connectors, individuals, people within your organization who sort of know the lay of the land, have been around for a while, or just have personal relationships with a bunch of different groups and teams. They're sort of, a social butterfly. And so you can go to them and say, hey, do you know who runs this team? Or do you know who I could talk to about a vuln we found on, this part of our public facing website, or this part of our mobile app for that matter? And they may say, oh yeah, I think it's this person. You already leverage those people. You just probably don't document sort of the directions that they're giving you. And so writing down what goes to whom begins sort of getting away from that tribal knowledge model of issue routing and starts to harden the documentation. And it's going to be wrong sometimes. You're going to send notifications to people, they're going to investigate, and they're going to say, oh, by the way, this is, hey, this isn't us. Like, I can't change this code because we're receiving it. This is a dependency for us. You have to talk to this other team. Great. You can go update your documentation and say, else if, et cetera, and drive better and better intelligence. The thing is, you're already doing, you'll already have started doing the manual legwork to figure out who needs to address what. You just have to do that organically in any sort of vulnerability management space. The key is documenting it in a way that you can use it again, that your teammates can use it again, that junior AppSec members who haven't worked at the company as long as you, who don't have those personal relationships, can drive those downstream notification delivery processes. So beyond just getting the notices or the messages to the right people, there's also the structure and content of the message itself. So you can't give a development team 30,000 issues in a CSV file. They're never going to sort of figure that out for you. You have to distill the information down into what needs to be fixed, what are the remediation instructions, and ideally, you would make it look as similar to their functional tickets as possible. Namely because it makes it easier for a development team to assign a security issue to a developer. And this is one of the areas where AppSec tooling tends to be very misaligned with the recipients of the remediation tasking requests, which would be the development teams. They're getting thousands of issues, but typically, as far as functional tickets go, they're only handling a dozen or 2 dozen tickets per sprint. How do you start engaging with thousands of tickets if you only handle, a couple dozen functional tickets in a 2-week sprint cycle, for example? Well, you probably just throw it to the backlog and never look at it. That's terrible. That means there's no risk reduction going on. So furthermore, this problem grows as your development surface area and your application security surface area grows. So as you add people to your AppSec team, and as you add development teams, and the complexity of the development ecosystem increases, where you have more people involved, maybe outsourced, maybe insourced, maybe additional different Scrum teams, maybe different delineation of responsibilities, the problem grows geometrically, double the nodes, square the connections sort of thing. So I mentioned before, using existing resources like organizational connectors. You can also use reference data sets like CMDB, application portfolio management systems, IP management tooling, Active Directory groupings, etc. The idea is to get away from tribal knowledge. determine what an issue notification will look like before you send the first communication. A great example would be getting examples of what functional tickets look like. How are those authored by product management, by the support organization, by developers when they author those tickets themselves, and try and model your transmission after that. And then finally, making the deliverable consistent with other tasks or tickets that the remediators interact with. So let's assume that you are able to facilitate intelligent delivery to the various teams and the various organizations and individuals throughout your organization, and it's in a format that's distilled, that is concise, that is legible, that contains all the information that they need. What do you fix first? So I have an ambulance here. When I was in high school, I was a ski instructor. And so every weekend, my parents would drive me up. It was like a 3-hour drive from my house to go stay next door to a ski mountain up in New Hampshire. And, you know, I would teach kids for Saturday and Sunday, and we would drive home Sunday night. Obviously during spring break, vacations, etc., you know, I would be there for 10 days or, you know, for long weekends, obviously longer. Well, one year we got a massive snowstorm, like a massive snowstorm. And this blizzard was dumping. And I was like, hey, I'll go work because I know school's going to be closed. So I hopped in the car with my brother and my father, and we were going, you know, on major highways where we'd normally be driving 65, and we were driving 30. And it was a single file line on a 4-lane each direction highway. And, you know, periodically you'd see an SUV fly by and they'd be doing 70, and then, you know, quarter mile down the road, you find them sideways in a ditch. Well, I will never forget the realization that prioritization is really, really important in emergency services when I saw people laying on the ground next to their car and an ambulance drove by them. It was like, I could not personally imagine a more serious situation that needed medical help, but there was clearly another incident further down the highway or previously on the highway that had already been met by that ambulance. And so there were emergency vehicles passing by this majorly critical vehicle accident. So what to fix and when? Where do you send the ambulance? Because you don't have an unlimited number of remediation resources. So everybody can sort of imagine there's an imaginary number of developer hours or dollar amount or story points that you could assign to remediate any particular vulnerability. And then there is a theoretical amount of risk, however you quantify it, that would be reduced if a particular issue were, you know, truly remediated. So you can draw sort of a matrix. I've got a 2x2 here, which is a nice little intellectual construct to use. And so everybody agrees on the first things to address: low effort, high risk reduction. Do the things that take the least amount of time, the least amount of effort, that yield the highest risk reduction return. Everybody agrees, don't focus your efforts on the things that are high effort to remediate and low risk reduction, because they're low risk and it's, you know, obstructive to all the rest of the development that's going on as to, you know, in terms of competing for those resources. So what do you do with the high effort, high risk reduction versus low effort, low risk reduction? Let's assume you've cleared your low effort, high risk box. Where do you go next? Well, development teams, especially DevOps oriented teams, tend to focus on or want to pursue low lows because they are low effort, which means that they are bite sized. That fits nicely within the iterative nature of DevOps and or agile. Security teams generally want to focus on the potential for high risk reduction, even if they're high effort, because they're really important. You can focus on a lot of low risk reduction issues, but you've still got this lingering, very high risk issue outstanding. And that's sort of what keeps security folks up at night. So how does a business prioritize what to fix after you've cleared the obvious stuff? Well, first and foremost, you're not going to run into this immediately. As you establish your program, specifically if you haven't been pursuing application security assessments against your in-house developed or your first-party developed applications for some time, there is going to be a massive backlog of low-hanging fruit that you can pursue. So oftentimes this doesn't show up for 12, 18, 24 months because that sort of obvious bucket to tackle is deep enough that you can just work on that for a year or two, or your developers can work on that for a year or two. Secondly, backlog versus net new issues. If you're doing ongoing scanning throughout the SDLC, theoretically, you're introducing assessments earlier in the development lifecycle, and so you're not introducing net new issues into prod. You'll catch the issues earlier, and those, what would be high risk issues will get caught before they make it out the door if you're, executing scans, against releases that are going into a dev environment and things like that. So typically, you're really focused on burning down the high risk issues of the backlog, not necessarily, and you're not going to see sort of a pace of high risk introduction issues in an ongoing fashion. So both teams are right some of the time. And a good way to think about this is bricks and mortar. If you imagine a brick wall, it's made up mostly of bricks and a lot of mortar. And many brick walls are actually 50% mortar and 50% brick, which is surprising to a lot of people. Because visually you would automatically assume that it's mostly brick. So the low effort, low risk issues should be tackled in an iterative ongoing fashion, just the way that developers would want to pursue them. The high effort, high risk issues need to be addressed in concert with the development team's own initiatives. So every application over time will typically evolve. If there's active development on an application, there's going to be architectural changes. There's going to be changes to the data model. There's going to be changes to key components like, the underlying crypto package, the authentication methodologies, the support authentication modalities. As development teams work through and re-architect those parts of their application security teams can piggyback on those functions or on those project-based moves to remediate sort of the outstanding high-risk issues. So you don't want to tell development, hey, you need to rip and replace the way that your end users authenticate into this web app. You want to say, hey, I understand that you are talking about potentially overhauling the authentication layer of this web application. We have some outstanding security issues associated with it. I would love to see that prioritized, and I would love to be at the early design and discussion table so that we can begin addressing, so that we can ensure that the risks that currently affect the web application aren't present in the new version of the authentication 2.0 model. So finally, compensating controls and individual point remediations that genuinely reduce risk in the near term, but don't necessarily fundamentally expunge the risk of a vulnerability. They're not true remediations, but they abate or they mitigate risk, are acceptable. Oftentimes, if that auth overhaul isn't going to happen for another year, but the risk presented in the current auth model is beyond what the business is willing to accept, a compensating control or a series of compensating controls can serve as a sufficient means to sort of close the gap between where you are now and a true remediation further down the road. It's not ideal because it's sort of cul-de-sac work, but there's often times where that's the optimal play so that you can be less disruptive to the dev cycles. And the developers generally understand that they're doing cul-de-sac work, so they oftentimes try and ensure that they're doing as little of that as possible. So those are the challenges that we oftentimes see in transitioning to a federated responsibility model. I would be sort of remiss to leave out the fact that Joanne and I work for an organization that provides a software solution that specifically is designed to solve for these problems. So the company is called ZeroNorth. The idea is an abstraction layer that interacts with the build and delivery pipelines and processing tools, as well as the ticketing ecosystems, essentially the entire development and engineering ecosystem, and to draw all of the results from all of the security scanning tools into the ZeroNorth platform, facilitate that sort of cooperative, accelerated pipeline delivery and empowerment of the development teams through orchestrating those assessment tools. So you plug assessment tools into ZeroNorth, where you enable ZeroNorth access to those assessment tools, and then ZeroNorth can normalize the way that those scans are executed. There's a bunch of advantages to doing that, not the least of which facilitating asynchronous scanning modalities within build pipelines. And once we gather all the data back, we serve as a single point of reference. So we facilitate analytics, we can deliver BI and visualization tools, we can drive ticketing and notification workflows so that automatically certain thresholds of vulnerabilities get reported back to the development teams. And essentially just facilitating this federated responsibility model by serving all the different stakeholders in the ways that they want to be served. A big portion of what we do is distilling the data output and performing noise reduction. So instead of delivering that 1,000 tickets over to your development team, you can deliver a couple dozen consolidated tickets that sort of encapsulate like-kind findings or thematically consistent, themes of findings that were discovered throughout the surface area of the application. So if you're interested, Joanne and I would be happy to chat with you. We have a sales team, and we can get sort of your local regional sales manager on the line to discuss. I'm one of our solution architects, so I take folks through the platform, explain how to use it, and talk about some of the use cases, specifically with regards to Federated Responsibility Model AppSec programs. So again, maintain enterprise standards, accelerate pipeline velocity, unburden and empower developers. That's what we're all about. And would love to hear your thoughts. So if there's any questions, would love to hear from you.
Yeah. All right, great. So we have lots of time for questions, guys. So if you do have a question for either Thaddeus or Joanne, please go ahead and use your GoToWebinar control panel, and we will go ahead and get to as many as we can. But here's the first one for you. Let's see, we have a security champions program. Where do they fit into the type of AppSec program you described?
Yeah, that's a great question. So many organizations, oftentimes large organizations, leverage a security champions program, which is a security champion is just somebody on the development team that is designated as the liaison to the application security group. And they tend to be, focused on leaning into the security issues. They will help their development teammates remediate issues if the dev team doesn't, that particular developer doesn't know how to overcome or remediate a specific vulnerability. So that sort of a program exists as sort of a precursor to the federated responsibility model. And oftentimes those people still serve the same role, because you don't necessarily want to be directly communicating security issues to all of the developers on a team. And it is extremely helpful to be able to engage in a dialogue with somebody who is both familiar with security and familiar with that application, with the application where the vulnerabilities were found. So that person can go and solicit feedback about the formatting of tickets, about the level of effort to remediate issues. If it's discovered that it's going to be substantially more complicated to fix something later down the road. And so oftentimes those people serve as sort of the primary communicators, the voice of the dev team to AppSec. And hopefully they're also championing security within the development teams. And so, if communications need to happen from AppSec to the dev team, oftentimes it can flow through that individual. And so we see security champions as a phenomenal resource for AppSec teams to be able to proliferate even a federated responsibility program. You may feel like you don't necessarily need the to transition to sort of address some of the challenges that we talked about with respect to the federated responsibility model. But even the greatest security champions programs can't really replace an intentional incorporation of developer responsibility, of operational responsibility, of business leadership responsibility at the AppSec table.
All right, great. Next question here. Let's see. My company's applications range from very mature orchestrated pipelines to semi-annual releases. I can see the benefit of this type of AppSec program for my fast and rapidly changing applications, but is there any benefit for my slower product releases?
Yeah. So tempo of release cycles has sort of dictated the need for a more rapidly responsive AppSec ecosystem. So 10, 15 years ago, when application security programs were first being defined, a lot of major enterprise organizations, you would have processes like release reviews. So a build process on a monolithic, quarterly released product would, the build would be performed, and then it would be delivered to security, who would essentially have it for 2 weeks to run their own assessments on it, and then come back to the table with findings, and then you have another 2 weeks where the development team is able to take the feedback from the security team and fix the things that security would establish as blocking that release from a risk standpoint. If you have slowly released applications that are only delivered 2 or 4 times a year, or once a year, you can probably get away with those processes. They're very manual and slow, and you're taking advantage of sort of the timing windows available in between the hands-on keyboard coding effort and the actual release of that software. I would say my perspective is a federated responsibility model is advantageous anyway, just because it's focused on efficiency and clarity. And so the mechanics of executing that federated responsibility model really lies in making the developers' lives easier, in helping the developers and empowering developers to execute risk remediation in a more rapid fashion that is less disruptive to their overall development cycle. So you could imagine, even for a slowly releasing application, they're still doing builds in the background. If you can incorporate the assessments into maybe the dev build process, so you can get that telemetry earlier in the release cycle, you're essentially doing the same thing. You're just doing it against an application that's only going to put out a new version once a quarter, as opposed to an application that may push to prod 4 or 5 times a day. So the velocity demands are less, but I think all of the benefits that are imparted to that very rapid-paced organization or rapid-paced delivery cycle are also afforded in the slower releases. It's just maybe not so obvious that it would be helpful, because you're not necessarily handcuffed to a really rapid pace. That's a really good question.
All right, great. We still have plenty of time for questions, guys. So if you have one, please go ahead and use your GoToWebinar control panel and submit it. Here's another one for you. Is there any feature related to security as a code, specifically for custom penetration testing?
Sorry, can you say that one more time?
Sure. Is there any feature related to security as a code, specifically for custom security as it says security as a code, specifically for custom penetration testing?
Yeah, I wanted to make sure the distinction between code assessments and security as code.
Got it.
That is a fantastic question. So in order to meet the demands of modern application development and release cycles, facilitating a federated responsibility model, application security really does need to operate in an as-code fashion. So what do we mean by that? Very few people manually configure and issue bare metal servers on a routine basis. There's probably more people, but still very few people iteratively sort of build VMs for production use on an iterative basis. Why? Because we can do these things as code. We can make API calls to software platforms. You obviously can't do that with bare metal servers. Hopefully you're not changing your infrastructure all the time, but certainly with cloud ecosystems, you can execute API calls to Azure or GCP or AWS and immediately have new infrastructure available. So what I believe the question relates to is, how do we achieve that sort of a functionality in the security space so that I can conditionalize the execution of scans, so that I can write code that will intelligently interpret input values and deliberate, make decisions on security type behaviors to execute. Do we block a build? Do we not block a build? Do we execute a dynamic assessment against this, release of the application or not? Well, this is destined to go to a dev environment, so we don't run DAS testing unless it's flagged for unless it's flagged as destined for production, right? The final dev version or whatever have you. Conditionalizing the execution of scan assessments, conditionalizing the delivery of vulnerability notifications in the form of code is fundamentally what ZeroNorth is all about. I mean, we have a very rich API interface for our platform, and that facilitates orchestrated execution of scans, retrieval of an index of how many criticals, highs, mediums, lows, investigating when was the last time a scan of this type was run against this particular type of application, so that you can ensure governance, that production releases are actually being assessed by the tools that you want them to be assessed by. All that sort of stuff, that's exactly what ZeroNorth is designed to facilitate. There isn't really an industry standard for security as code, but it's become a much more popular topic. And all new security tools that I've seen in the last couple of years are releasing with API addressable capabilities, so that customers can design security as code, either within their pipelines or within just their own business processes. But yeah, that's 100% the direction that ZeroNorth has leaned into, and that's the easiest way to proliferate an AppSec program across a broad application portfolio.
All right, great. We have one more question here. Guys, one more time, if you have a question, please go ahead and use your GoToWebinar control panel. We have time for one or two more questions, so go ahead and send them on in. Here it is. Next question. My devs already have thousands of backlog security tickets in their backlog. Most of it they haven't touched. What should they do with all those tickets that my team already created for them?
That's a great question. So you've already kicked over thousands of issues because likely you have noisy assessment tools that produce either a high volume of false positives, or the way that those assessments are performed, they produce a high quantity of findings, even if each of those findings doesn't necessarily represent a discrete remediation task for the development team to pursue. So it's painful to sort of abandon mountains of work that you've already done. If in a moving forward fashion, you can oftentimes pivot to newly discovered issues that are sort of, I wouldn't recommend going back and sort of reconstructing thousands of tickets to change the format or to reprocess the routing. Oftentimes when you run a scan, the scanner will emit information about what is the current vulnerability set, because it's going to find the same vulnerability if it hasn't been remediated. So you do have an opportunity to sort of perform novel analysis and distillation of the vulnerabilities as they're emitted by the tools, because if it's sitting in the backlog, it quite frankly hasn't been fixed. So if you can condense and consolidate that finding that you may have already created a ticket about, but you can reconstruct it in a way that it's much more likely to get a developer to respond and actually remediate that issue, I would say it's worth the effort to sort of redo the issue construction. Hopefully you're not, hammering these out by hand, but a lot of teams do. And it can be super frustrating when somebody comes along and says, hey, the thing that you've spent the last you and two of your colleagues have spent the last 6 months on, we need to overhaul these. Changing tickets in place is typically better because the created date on it is much closer to reality in terms of indicating when that vulnerability was found. So if you can start consolidating tickets in place, or working issues or tasks under epics or story type tickets, so that you can create more streamlined consolidation of those issues. I would say definitely talk to your development teams about how they use those constructs within their development cycles, so you don't sort of throw a bunch of noise into their dashboards. But for the most part, you're going to have to go over it anyway. Because if you've just been emitting raw issues to the dev team, raw in the sense that you just take the finding from the scanning tool and you hand it to the developers, they're probably not engaging with those in a proactive way. If you have an SLA around it, you obviously want to maintain the telemetry on when those issues were communicated, but hopefully they're not out of SLA on thousands of backlogged issues. In the world of ZeroNorth, we do a lot of compression. We see compression in the hundreds to one, thousands to one, where a finding that appears many, many times throughout a particular scan actually is thematically consistent. And so we can emit that as a single ticket, and it may require, multiple corrective actions to be taken, but you actually want one developer working on that ticket. You don't want 5 different developers to sort of get 20 each, and they each figure out their own way of putting a Band-Aid on it. That's not a good way to go about reducing your risk, because those sorts of things are flimsy or inconsistent, and then you end up with more complex remediation tasks down the line, just because the development team sort of sprayed tasks across their people to more equitably spread the security load.
Okay. All right. Well, we're 3 minutes to the top of the hour, so unfortunately that's all the time that we have for question and answer period. Got some great questions in, so thank you to everybody who did submit questions. Really good stuff there. Also, I want to really quickly remind the audience that today's event has been recorded, so if you missed any or all of it, or if you just want to watch it again, you'll have the opportunity to do so. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. The webinar is also going to be on the Security Boulevard website, so you can always go look for it there. Just go to securityboulevard.com/webinars, look in the on-demand section, and it should be right there waiting for you. Okay, I also mentioned at the top of the hour that we would be doing a drawing for 4 $25 Amazon gift cards. So real quick, let's go ahead and get that done. Our first winner today is Janice G. Congratulations, Janice. Our second winner today is Jennifer G. Congratulations, Jennifer. Third winner today is Marilyn H. Congratulations, Marilyn. And our final winner today is Victoria G. Congratulations, Victoria. I think that's the first time we've ever had 4 female winners in one drawing. That's I don't know statistically what the odds are there, but maybe you guys should go get a lottery ticket. Also want to thank today's speakers, Joanne and Thaddeus, for a great presentation. Amazing stuff. Thank you so much for the information. Thanks for your time, your expertise. Really appreciate it.
Thanks so much, Charlene.
Thank you.
Also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I am signing off. Have a great day, everybody, and please stay safe.